Hi everyone, this is Niranjana Gayatri from the Department of Artificial Intelligence and Data Science. In this video, we are going to see a presentation which is about the hidden Markov model. Okay, now let us move on to the contents which will be covered in this presentation. The first thing, you will get a clear idea about what is a hidden Markov model, and then we will see a Python program along with its algorithm for the implementation of the HMM, and the program with its output will be displayed over here. Next, we will see the applications of the hidden Markov model. Finally, we will look upon the limitations of the HMM, like the disadvantages of the HMM model. Okay, as I said earlier, you will get a clear idea about what is a hidden Markov model. Okay, let me explain you this. A hidden Markov model is a statistical model, so which is used to describe a system where you have observations which will be generated by one of several underlying states. The key idea is that the states themselves are not directly observable, but we can observe some outcome or output that is dependent on the underlying states. Okay, now let us move on to the implementation of the Python code. Here is the algorithm behind the Python code. Let me explain you this in the next slide along with the code so you will get a clear idea about this. So here is the Python program for the implementation of the hidden Markov model. First of all, we need to import the necessary libraries. So here we are using the NumPy library. So this code implements the forward algorithm for a hidden Markov model to calculate the probability of an observed sequence and determine the most likely sequence of the hidden states. Let us break it down step by step. The first step, we need to initialize. Here, we are initializing the transition matrix, so which represents the probabilities of transitioning between the hidden states. Next, we are initializing the probabilities. So the initial probabilities of starting in each hidden state. Next, we are initializing the observed sequence, so which represents the emissions. Next, we are representing the emission matrix, so which represents the probabilities of emitting each observations from each hidden state. The alpha matrix one to store the forward probabilities for each time step and the hidden states. Second thing, we need to calculate the forward probabilities, okay? The first entry in the alpha matrix is calculated using the initial probabilities multiplied by the emission probability for the first observation. Next, for each subsequent time step, the forward probabilities are calculated based on the previous forward probabilities, emission probabilities, and the transition probabilities. Third thing, we need to calculate the probability of the observed sequence. So the probability of the observed sequence is the sum of the forward probabilities for the last time step, which represents the total probability of all paths that lead to the observed sequence. Finally, we are determining the most likely sequence. For each time step, the code checks which hidden state, for example, sunny or rainy, has a higher forward probability and appends the corresponding state to the most likely sequence list. Finally, this code prints the probability of the observed sequence and the most likely sequence of the weather states based on the HMM. So here I am displaying the output of the code. See, the probability of the observed sequence is 0.0189 and the most likely sequence of the weather states is sunny, 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 rainy, rainy and sunny. Okay. Now, let us see the applications. We have various applications behind the hidden Markov model. Let me tell you some of those. The first one is the speech recognition. So, the HMM are widely used in automatic speech recognition systems. Like they can model the probabilistic relationship between the spoken words and the acoustic features of the speech signal. The next one is a natural language processing. HMMs are utilized in various NLP tasks such as a part of speech tagging and speech synthesis. They can model the probabilistic relationship between the words in a sentence and the grammatical categories or the semantic meanings. The third one is bioinformatics. In bioinformatics, HMM are used for tasks such as a gene prediction, like a protein sequence alignment, and modif- modif finding. They can model the probabilistic relationship between the DNA or a protein sequence and hidden biological structures. Next, the financial time series analysis. They can capture the hidden states underlying the observed market behaviors. Okay. Finally, the gesture recognition. So the HMM can be used to recognize and interpret human gestures in applications such as a sign language recognition, human computer interaction, and emotion analysis. They can model the probabilistic relationship between the observed gestures and the underlying gestures or actions. Okay, now let us move on to the limitations of the HMM, like the disadvantages which we are having in a hidden Markov model. The first one is assumption of stationarity. The HMM assumes that the underlying system being modeled in stationary, meaning that the transition probabilities between the states and emission probabilities of observations remain constant over the time. In many real world scenarios, this assumption may not hold, leading to inaccuracies in modeling the dynamic systems. Limited modeling of dependencies. The HMM model dependencies between consecutive observations through the Markov property, which assumes that the current state depends only on the previous state. This limitation can be restrictive for modeling the complex dependencies where the current state may depend on multiple previous states or the observations. The next one, the difficulty in capturing the long term dependencies. What it is actually? Okay. Due to this, the first order Markov assumption, the HMM may struggle to capture the long term dependencies in a sequential data. This limitation can be problematic in applications where understanding the distant dependencies is crucial. So, such as in natural language processing tasks involving long sentences or the documents. Okay, that's it for today, and thank you for watching.